Hello, welcome to this tutorial where I'll show the step-by-step process on generating a 3D model in Agisoft Metashape of a sponge colony and scaling it to a very high degree of precision. Okay, so it starts here with a pictures folder full of pictures that you took underwater. In this case, it was taken by a Canon PowerShot G7 Mark II in an underwater housing. This was a sponge colony of the Cliona genus, taken in the Mexican Caribbean. As you can see, there are many overlapping pictures from various angles. Each picture shouldn't be too far away from the previous picture, so you want a lot of overlap and very gradual movement as you take photos from all angles around the colony. There is also a rod that was drilled in as a permanent fixed point because the purpose of this particular model is to compare the sponge colony and how it changed from one point in time to the next point in time. So for me, it was a requirement to have a permanently fixed anchor point so that I could measure how much the sponge moves or erodes down into the surface. But this depends on your own needs for a 3D model, whether you want to drill in a rod or not. One other thing that is very important is the presence of a scale. So over here we have a foldable ruler with very clear markings on every centimeter and millimeter. It's not necessary to have these GCP markers. I didn't use them for this model, but it's important to have this so that you can scale the model properly. It is recommended that you should have more than one scale spread out far apart so that the model won't distort where everything is. But in this particular demonstration, I only have one ruler that extends in two different directions. So once you have all of these pictures loaded, open up Agisoft Metashape Pro and save a new project. So I'm going to find the same area where the pictures are in, and I'm just going to call it. Okay. Once again, you might notice that there is a PSX file, which is the Agisoft file, and a .files folder. Make sure they always have the same name. If you change the name of one, you must change the name of others, and keep all of these folders together in the same place. If you change the positions of anything, you're going to have to reorganize the paths of the directory for Agisoft to find back your pictures and find back the files. So now that we're here, go into the Workspace tab, right-click on Chunk, Add Photos. And you simply select all of the pictures that you want to put in, and they will show up in the Photos pane over here. If the Photos pane does not exist for you, you simply have to go to View, Photos, and you can activate it here. One other thing is that this is in English. If you prefer another language, you go to Tools, Preferences, and you can change your language to whatever you want. I'm using the classic theme. There are other themes that make the screen look different, but classic is the one most people use. So you can look through all of your pictures in the Photos pane over here. If you have any bad pictures, you can remove them by simply right-clicking and removing cameras or disabling them. Either one would work. If there are things blocking, like in some cases your hand might get in the photo, or you have a photo where the sea fan sort of blocks the entire thing, you might want to remove the photo as well, or if it's very blurry. But I'm happy with all of these photos, so the first step is to go into Workflow and Align Photos. You want the highest accuracy in general, and press OK. This can take a few minutes or a few hours if you have a model of a lot of pictures. This one has 87 pictures, and it depends on your computer's power as well. So I'll resume the tutorial when this is done loading. But in the meantime, I would recommend using the background function. So it will clear the screen and it will automatically save when the model is done processing. As you can see, the loading bar is over here. And that's quite helpful because if you don't run it on background and you just keep the loading bars up here, if it finishes loading and somebody comes to the computer and X's it out and doesn't save, you've lost all your progress. But if you run it on background, once it's finished, it will automatically save, and after that, nothing can really go wrong. So yeah, I'll see you in a bit. Okay, the photos have been aligned. Since the progress bar is now gone, I'm just gonna reopen this file. And you can see here the sparse point cloud. So 100,000 plus points, These are consisting of tie points, which is basically all points that the software can detect that exist on multiple photos, that sort of tie all the photos together. And that's why the software now has a rough estimation of where each photo was taken. So this is roughly what you want to do. Make sure you capture it from all angles. It's not so important that you take photos from very close, unless you want to capture a lot of small details. In which case, when you capture very close photos, make sure you gradually come out to the wide angle and go all around. Because if you only take close photos and far photos, the software is not going to be able to tie them together. So now that we have this, the first thing we want to do is get rid of the bad points. So these are the error reduction steps. So you go into the reference pane and scroll all the way to the side. You can see the error of each picture that you took. So this means that for this one particular picture, there's a possible error of 2.5 pixels, where any point that the software identified from this picture could be 2.5 pixels off. So we want to get rid of the bad points. And the first thing we do is go into Model, Gradual Selection, and Reconstruction Uncertainty. So whatever this level is, you want to choose a much lower number, something like 20 or 30, that would get rid of about 1/3 of the points. So about 32,000 of these 100,000 points have an uncertainty of above 20. So 30% is about what you want to get rid of. So you select this. All of the red points have been selected. They are the 32,000 most uncertain points. Just press delete and they're all gone. Now we have 68,000 left. And we want to click on this magic wand and optimize the cameras. Don't worry about what is ticked and what's not ticked. You don't have to change anything, just optimize. This will only take a couple seconds, and once done, we'll go back to gradual selection. And this time, instead of reconstruction uncertainty, we're going to go with projection accuracy. We do the same thing here. Something around 5 or 7 should be getting rid of 1/3 of the points. So 8,000 is selected. I'm looking for more like 20,000 points selected. So I can go a bit lower. 13,000, 21,000. Okay. So about projection accuracy, everything above 3, these 21,000 points, we can delete them. So okay, press delete, 46,000 left. Now we go to settings and we make the tie point accuracy 0.1. After this, go back to the magic wand, optimize the cameras again, and click on all the boxes. Whatever boxes are unchecked in this general box, just check them and press OK. If you get this warning, it's alright, just press yes. That means that there are some photos that have very few good points, and in that case it might be better to just ignore the photos. So as you can see, if you arrange the photos by amount of error, now the highest error photo has 0.6 pixels off, which if you remember at the start it was 2.5. So we've reduced the error by quite a lot by getting rid of, well, so far about half of all the bad points. Now we're not done yet. Go back to gradual selection, reprojection error, and this time we're going to choose about 10% of the points. So let's see, 0.5, we can go lower, 0.4, 0.35, okay, 0.4 seems good, about 10% of the points. Remember this value is 0.4, we're going to do this a few times. So you press OK, delete, optimize cameras, and then we do it again. 0.4 again. As you can see, it's still selecting points because every time we re-optimize cameras, some points become bad again. So you want to do this a few times to continuously get rid of the bad points, optimize, get rid of the bad points that come out, and repeat. So delete those 300 points, optimize, partial selection. So you can see the level is getting smaller and smaller, so there are less and less outlying points every time you do it. Now there's only 134. Delete them. You can do this 3 or 4 or 5 as many times as you want. I usually stop at about 4 if it looks like the number's going down. 64 selected. Yeah, I think that's good enough. So you optimize it one last time. And that's your points. The next thing you want to do before you go on to the next step is to make sure your bounding box this region over here, this box, is in the correct area. So what that means is that in the next step, only the points within this box will be processed. So if you look over here, there are these few points that are sticking out of the box. Okay, this is the top of the rod, and I want that in my model. So I need to make sure the box becomes a little bigger to contain it. So to do that, you find Move Region, and you go to Resize Region. And you simply make sure it covers everything. Now you can make the region smaller as well. So for example, if there's a lot of points outside that I don't really want, I want to focus on this sponge colony, I can make the box smaller. Since I don't want it to spend so much time on processing, the next few steps could take quite a long time. So I'm going to limit the box down to contain one scale. Make sure you have at least one scale. Best to have two. Best to have this scale as well, but this scale, I put it to the side. If I had wanted this to be used, I would have put it closer. And make sure you look at it from all angles, that you're not cutting anything important off. So I'm happy with this box right now. You can go back to just navigating. And the next step is to create a dense cloud. So this is a sparse cloud. Now we're going to use each picture to fill up the gaps. So you go into workflow, build dense cloud. The quality, if you want it to be higher, you can go higher, but medium usually is good enough, because the higher you go, it will increase the processing time, but not increase the quality by a lot. So I find that medium is the best of both worlds in terms of processing time and quality. This is one of the longer steps, so make sure you go onto background, especially if you're running this overnight, and I'll see you when that's done. You open it, and to see the dense cloud, you will click over here, and yeah, so these are still made of points. Now it's about 3 million points as opposed to the sparse cloud, which had 40-something thousand. So you can see that it's still made of points. It's not a surface yet, but it looks a lot better already. From this point, you can continue on to the next step, which is to build a mesh. But what I like to do is to do freeform selection and get rid of some of the points that I know I'm not really going to use. So you select them and press delete, and you get rid of a few points. You can go all around. If you want, you can just reduce as many points as you want over here, of areas that you know you're not going to need, because that would reduce the processing time for the next few steps. So I'm just going to get rid of some of these points. It's not very important that you do this, but I like to save every bit of time. And yeah, so now I've cut out about 1/3 of the points. We can continue on to build the mesh. So the source data should be dense cloud, arbitrary, phase count high. And you press OK, and it's another waiting game. So I'll see you after this. Alright, now the mesh has been generated. I opened it up already, and as you can see, it looks worse than the dense cloud actually. The dense cloud looks a little more detailed, but that's because there's no texture on it yet, so all we have to do is go to workflow, build texture, keep these default settings, and wait for a slightly shorter amount of time. Okay, now we have our textured model. You access it by going down to textured. This looks as good as it's going to get. And what we're going to do now is we're going to scale the model, because Agisoft still doesn't know how large this is in meters or centimeters. So we're going to use the scale here and bring ourselves down to an extreme end of one of the scales. Make sure that this flag is activated, the markers icon. And I'm gonna zoom in to where I want to go, which is this marker right here at the 81 centimeter mark. So just find an identifiable point at the extreme end of one scale, and I'm gonna name this 81. Okay, now I'm gonna go to the other end of it. Make sure you stay on the same side. So this is the top side, so I'm gonna stay on the top side. And go down to here, put a marker. I'm putting it slightly above the marker because the the 81 centimeter marker was a bit longer than this one. This one is the 61.5 centimeter mark. So 61.5. Okay, I'm gonna do the same thing on this ruler. So at the 61 centimeter, I'm gonna put a marker right here, 61. And then I'm gonna go over on the bottom side to the other side of it, and I'm gonna go here. This is the 42 centimeter mark, I think. 42. Okay. Now you have two pairs of markers, one for each ruler, and you're gonna select each pair, one pair over here using the control key, create scale bar. So you can see it over here. I'm gonna do the same thing for the other pair, create another scale bar, and I'm gonna input the real distance over here. So the 62 centimeter to 42 centimeter mark is 19 centimeters away from each other, which is 0.19 meters. This one is 0.195 centimeters apart. Once you've put this in, Agisoft doesn't scale it until you press this update key. So once you press it, Agisoft has scaled the model to best fit the two scales that you have put in. It won't be perfect. So you can see that there is a little bit of error. So the error is about 0.2 millimeters. So 0.2 millimeters for about a 20 centimeter scale, that's like 1%. So I think that's pretty good, considering that the sponge isn't very much bigger than the scale itself. If the sponge was really, really large and you have a 1% error, it might translate into a little more uncertainty. But considering the sponge is this size, that's pretty good. So now this is scaled, we are pretty much done with generating the 3D model. So your next step is to export whatever you want to export. So for my particular project, I'm going to be comparing how the sponge changes from T1 to T2. So I'm going to be exporting the points. So what it's basically exporting, I'll show you, is the dense cloud. I want these 2+ million points to go into the next software, Cloud Compare, which will be the second video in this series, which I'll show you how to use Cloud Compare to find the change in the sponge. But for now, this is what we have. You can do quite a lot of things with this. You can keep the model as it is. You can export the model itself onto a program like Blender and some others as well, like Sketchfab. You can export a DEM, which can show the elevation, express this in a map and show the elevation, and a lot of other things. So the reason why I've bothered to process past the dense cloud phase into the texture is so that I can have a better look at these mirrors to scale the model more accurately. Actually, for my purposes, since I only need the dense cloud, if I was able to scale it as well in the dense cloud, I wouldn't have needed to go into the mesh in the texture. But I did that extra processing to make sure that I got the scales really, really good before exporting back the point cloud. So yeah, that is the tutorial complete. Part 2 will be on analyzing the erosion, or in some cases the growth of whatever you 3D modeled. It could have been a sponge that erodes or a coral that grows. Yeah, you might not need the second video, but that's going to be what it is. So see you.